All right, so earlier when we were doing palindromes, we talked a little bit about regex, but we really didn't get into any detail about that. So let's talk a little bit more about that. So regex also is short for regular expressions. And so essentially what a regular expression is, get out of here, it's a pattern. And specifically the ability to use patterns to match character combinations in strings. And every coding language has slightly different patterns on how to match these combinations. They usually work more or less the same way. Like earlier, I showed you a tool called Rubular, which even though it's a Ruby tool, most of the patterns there are exactly the same as you'd use in Python and JavaScript. There are actually other tools more specific to whatever language you're looking for. You just need to, like if you just Google Python regex cheat sheet or what have you, you'll find that as well. But the way regular expressions works is essentially like this. A user inputs some text, then your compiler reads that input and then uses the regex pattern you create to match it. And then that usually will return some kind of Boolean, whether there is a match or not. And then your code will do something based on whether or not it finds any matches. So can anyone think of any like real world situations why this would be useful?
Password.
Yeah, password evaluation.
Yeah,
Phone
validation
number.
in general.
I heard a few things.
I just said validation in general.
Yeah, it's very useful for validation. So if you're making sure you have a properly formatted email address, like many websites do. Like nowadays, you can't just type in something where it looks for email. It'll say, hey, that's not a valid email address. Please type in a real one. Essentially, they're useful for anything where you're relying on user input, and we have to understand that users are fallible, extremely fallible sometimes. So like another example that comes up very often in regex is phone numbers. Everybody has different ways of writing phone numbers. Some people write them as 800 555 555, but they may also use something like this, or they may do this, or any combination of these, but they're all phone numbers. And we may want to make a program that could say, I want to recognize a phone number regardless of the way in which they write it. So I'm going to be demonstrating how to use regex in Python this time, but JavaScript also has a lot of Python things. One thing that we want to keep in mind as we're using regex is we want to use Python has something called raw strings instead of regular Python strings. And you do this by prepending a string like this. So you say R and then string. And a raw string in Python is functionally identical to a regular string, except for the fact that it can recognize escaped characters. Or maybe do I need to put parentheses after? Let me try running.
I don't think so.
Yeah. Yeah, there we go. Yeah, so it's just R and then the name of that. And that is useful for regex because then it can detect things like new line characters as escaped new line characters instead of just ignoring them it would with a regular Python string. So as we go forward and you're using Python with regex, just always make sure you put that R in front of your string so that you're looking at the raw version. Does anyone have any questions about what regex is before we get into how to use it? All right. In that case, I'm going to import a library that Python has built in called RE, which is short for regular expressions. And the RE library has a lot of great, just a lot of amazing functionality. So I do Python RE library. You can take a look at some of the documentation and see all of the different kind of functions that it makes available to us. So it's got all things of regular expression syntax. And then they have things like search So there's a lot of different functions here. We're going to go over just a few of these. So first off, I'm going to create a string. I want to make a function that can detect a date, like, you know, May 13th, to use today's date example. So I'm going to make a string to search through. Let's call it. I'm going to say May 13. And then I'm going to make another variable to keep track of my regex pattern. So to do that, I'm going to say, you know, I'll call this regex pattern. And I'm going to make this a raw string. And then I'm going to figure out what my pattern is. So let's figure this out before we actually dive into what the regex is. Let's figure this out in layman's terms. What is the pattern for a date in this general format?
Looks like a month in a string form, and then day in as integers.
Yeah. So we've got the first half is we've got letters, then we've got a space, and then some numbers. So
And there's one capital also.
one capital, but let's say we want to make sure that this will find it regardless if they mess up their capitalization. So I could, set up a few, so it could be May 13th, but maybe they wrote it as May 13th, or even May 13th. I want to make sure it can detect it regardless. So to do that, we need to come up with a pattern that can account for as few as 3 and as many as, I don't know what the longest month is and how many letters it has. And maybe I just want to say, maybe even just any kind of letters. I just want to figure out it has that particular format of some letters, space, some numbers. So to do that, I'm going to use another tool called Pythex, which is like Rubular, but it's specifically for Python. And they have a cheat sheet as well. So first off, I have letters, but they could be any letters. So if we kind of take a look at this, so I want them specifically through letters. Let's see, is this giving me anything I'm actually looking for? Because I'm not sure yet. All right, so I don't know, I'm not particularly a fan of this cheat sheet actually, but they have an example here which has a brackets, then has 5, and then B-D. And it says here that would match any characters, 5, B, C, or D. So those brackets allow us to make a, what's it called? Make a grouping. And then we can define a range of things using B through D. I'm actually going to go back to the Rubular cheat sheet because the Rubular cheat sheet is a lot more readable and useful than this one. So for example, they have down here, bracket A to Z, A to Z. And so that'll give us any single character in the range of A through Z. So maybe I want to do something like A to Z, A to Z. So that'll give me any one of these letters, but just one of them. So then if I want to say, all right, there has to be at least one of these, looking through this cheat sheet again, I can find the plus operator. And the plus operator says one or more of this. If I want one or more of any letter A through Z, I can just put a plus there. And then if I want a space, I can actually just put a space. And then I want some number of, some measure of, some combination of numbers. So maybe I would want to look here, and they have something called /D, any digit. So I can do \D. And then I want at least one or more, so I can use the plus sign. Let's try this out. So here's I have my pattern. So I'm going to be using a few of these. I'm going to be using search, regex search functions. I'm going to print out re.search. And search takes in the pattern and the string as arguments. So regex pattern, string. And it'll return, let's see what it returns before we do anything else. So we can see here, we got something called a re.match object. Span equals 0 through 6, match equals May 13th. So that's kind of cool, but it doesn't really tell us exactly what I want. But essentially, this match object is something that the regex library does that allows us to say, okay, you found something. So maybe I can figure out, okay, what actually is in here? What if I do dot match? Can I do that? Nope, can't do that. So I need to figure out how to get the match, like it tells me there. I'm not sure. Let's see. Let's take a look at the match object thing here, because we have something here called match objects. So it says match objects always have a Boolean value of true. Since match and search return none when there is no match, you can test whether there was a match with a simple if statement. So if I do, so it looks like if we couldn't find a match, then it wouldn't do it. So that's cool. And then let's see what if we can kind of look about this a little bit. So there's something called match.expand. So let's try .expand and see if that's more kind of illustrative of what we actually found. Oh, I actually need to call the method. Otherwise, I'm just saying, here's a method. It's missing a required argument template. Okay, maybe I'm not looking at this right. So return the string obtained by doing / substitutions on the sub template string template as done by the sub method. All right, that's maybe not exactly very helpful.
You want the group method to get your match?
Yeah, looks like I want the group method. So I do group. There we go. So in this case, it found them. So search found it, and this is what like it said. So and here's what it found.
Can you also put in parameters like so that you don't get like a false value? Like for example, like I think with yours, you could have like May 99th or something like that if somebody was entering it in actual use.
Mm-hmm. Yeah, at this point, like this is a relatively flawed pattern in terms of it just gives me any combination of letters and any combination of numbers. So I could do Meowgly, and that should still be a match. Because all I told it was give me any combination of at least one letter and any combination of at least one number. So you're right. So the more specific you can be with this, the better. But also the more specific you are, the like using regex to find very specific values gets progressive, like exponentially more complicated, as you're going to see today. So you're right that this is a very simplistic solution, but it does work, at least. All right, so in any case, this is the search function. Let's take a look at another one called, it's almost the same thing, it's called match, and see what the difference is. So it looks almost identical. So they both return a match object. So the difference is that, I believe the difference is that search will find it anywhere. Match only returns the first one. Let me double check this. So if I do, what's the difference between search and match? We do, search versus match. They have an entire page for this. So Python offers two primitive operations based on regular expressions. Match checks for a match only at the beginning of the string, while search checks for a match anywhere in the string. So that's an important distinction there. So in this case, they both found May 13th because I told it to, because May 13th is at the beginning. But presumably if I did put a bunch of white spaces there, perhaps that would break it. Yep. So search just said, okay, I didn't find it here, but I did find it here. So I was able to find May 13th, match, start at the beginning and said, oh, no, it's not there. So there may be different ways to do this. It all depends on what you're really looking for. I'm going to show you one more of these. So I'm going to say print, I'm going to use re.findAll. I'm going to use the same regex pattern, but instead we're going to use June 6, August 10, December 24, and see what comes out this time. So as you can see, in this case, it returns what looks like an array with every match that it found in this string. Any questions so far about how this is working?
And the find all, it specifically looked for a combination of characters, then a number, and then it stopped.
Mm-hmm. Yeah, so you can see like white space in between these is not included because I didn't include it here. And I could mess this up if I put a space right there and then run this. My only matches now are June 6 and a space, August 10 and a space, but didn't do December 24th because there wasn't a space. So you can easily mess things up that way. Nope. Oh, forgot the. There we go. All right. Any other questions about how this is working so far? It's all making more or less sense? Okay. In that case, I'm going to continue on a bit. So I'm going to find another regex case. Or just like, I'm going to kind of expand a little bit on the find all function. So I want to say, all right, I want to say matches is equal to re.findAll. I'm saving all of these to a variable now. And then I'm just going to loop through them. So I'm going to say for match in matches, I'm going to print out full match is match, like so. That just looks really nice. But okay, so just finding things is a very basic function of regex. But you can also do things like, like what we did in I'm totally blanking on what we called that.
Palindrome?
Palindrome, thank you. We can also do something like in palindrome where we can actually change our string by substituting stuff. There we go. Thank you very much. So I'm going to keep my regex pattern the way it is, but let's say I want to replace things somehow. So in this case, I would have to find a method to do that. And if I can find one here pretty easily. Let's take a look. Or not. I know what it's called. All right, so there's something called re.sub. I'm trying to figure out how to find it. One sec.
I think all of them are prepended with RE, so you can type re.sub and it will take you all the way down the page. Oh, you got it, never mind.
Yep, re.sub. So it takes in a pattern, REPL, which stands for replacement, and string. It also has optional arguments for count and flags. So it says return the string obtained by replacing the leftmost non-overlapping occurrences in pattern in string by the replacement. If the pattern isn't found, string is returned unchanged. So it can be, and it says here, REPL can be a string or a function. If it's a string, any backslash escape is in it are processed. That is, a new line character is converted to a single new line character, etc. So they have an example here. So here's their pattern that they're looking for. which is a very complex regex pattern. And then they have this thing right here. I don't like that example. Let's try to make our own. So let's say we want to, I want to change all of my dates here. So June 6th, August 10th, December 25th. I want to change them so that they become 6th of June, 10th of August, 25th of December. Or at least we don't need the th at the end, the th, just the number. So in this case, I'm going to be doing something a little bit interesting. So I'm going to print re.sub. I'm going to have my regex pattern as my one pattern. I'm going to make sure that I put in my string here before I put in the replacement, because the replacement is going to be a little different. Because what I want to do is I want to make sure that I can group all of these in different ways. Essentially, I want to make sure that I can take this, kind of save it to a variable almost in regex terms, and swap it around with that. And to do that, I'm going to have to make use of another regex thing, which is parentheses. Parentheses allow you to group things together. So I'm going to put parentheses around this and around that. And what that's going to do is that's going to save in each of the matches it finds, it's going to save them as essentially numbers. To do that, I'm going to say right here, I'm going to do a raw string, and it saves those as /1, /2, etc., depending on how many groups you have. Since I have 2 groups defined by these parentheses, I should just be able to do /2 of /1. So if I get out of here, let's try this again. And maybe I want to say I put a comma after that. There you go, 6 of June, 10 of August, 25 of December. So those parentheses can be very powerful. And kind of the big difference between very basic regex operations and more complex regex operations is being able to master grouping and saying, okay, I want to replace this with the second pattern you find with the first, or sorry, with the second group in the pattern with the first. Does that make sense? I know this can be a little confusing sometimes.
I think it's a little annoying that the index starts at 1.
Yeah. Yeah, it is a little annoying that they do that instead of 0, like rational human beings, but what can you do? So you're going to be doing a very deep dive into regex today for most of your challenges. And if I kind of open that up real quick, we can kind of see what you're going to be doing. One sec. Because the first thing you're going to be doing is using this thing called regex 1, which is a series of lessons and challenges that'll kind of give you a big grounding in there. So for example, exercise 1, it's like, okay, we want a pattern that matches all 3 rows. All right, looking at all these 3 rows, what do they all have in common?
ABC.
ABC. And so essentially when it says it's looking for a match, it's just saying, can we find the pattern in this line somewhere? So we could also do, our kind of, we could do A through Z to just find, okay, we found that, or we could just even do A and it still counts. So that's pretty simple, but it gets more and more complex as we go through it. So, and they have a nice cheat sheet here as well for how to do that. So only A, B, and C. They have lots of different ways, shortcuts and things like that to do. So experiment a lot with these. Try to have fun with it. It's a lot like it's like a big puzzle in some ways. And if you ever want a really big challenge, there's another place called RegEx Golf. I love this. It's like match all of these and none of these, and it's like, what the heck? It's tough. It's really, really tough. But if you find yourself really enjoying it, like the first one they have is match all of these and none of these, and so oh yeah, they all have foo. But then it gets more difficult as you go on. Any other questions on regex before we move on to our next subject? Has everyone feeling excited to tackle it? Okay. In that case, I'm going to open up create a new file. So this is also something we touched on during a previous, when we were going over some of the other challenges. Because we talked about earlier whether or not we were mutating the original array when we were going through binary search, right? So what did I mean by mutating like whether or not we were mutating the array?
Whether you were changing the one that was already there.
Mm-hmm. Exactly. The idea is when I ran binary search, if I had saved array to a variable before passing it in, and if I had printed it out after the function was over, would it be the same array or not? And if it was the same array, we would say that this function was non-destructive. But if it did change it somehow, we would say, oh, it is destructive. So again, just rephrasing, destructive methods always change the original data, and non-destructive methods don't change the original data. They just return something new. And you always have to be careful when you're working with these, because it isn't always obvious in Python or JavaScript which methods are destructive and which aren't. So if we look at an example, so I've got a string here. If I run first name dot capitalize and then print out first name, what do we think is going to happen? Any guesses?
It'll print your name, but not capitalized, because dot capitalized, I think it only returns something, right? It doesn't change it.
Exactly. So when I run first name dot capitalize, it returns a version of this string with the first letter capitalized, and it leaves the original one untouched. So I could, if I did first name equals first name dot capitalized, then I'd be reassigning the variable. But in this case, it leaves it unchanged. All right, I'm going to try another example. I could do, last name equals Heinrich. And maybe I want to say last name dot replace, and replace every E with 1, 2, 3. Every I, because I have more than one I in my name. And if I do that, so if I print out last name, again, do we think this one is destructive or non-destructive?
Destructive.
Non-destructive?
No, destructive.
Let's try it. Replace is a non-destructive one too. So
I would think that's because strings are immutable versus lists, which are mutable. I think the same would go for tuples too. They're immutable.
Yep. So with Python, usually most string methods are non-destructive because the strings are immutable in Python. In JavaScript, it's not always so clear cut. But someplace you may find where you have more destructive methods is when you deal with things like arrays. But staff equals Noah and Tom and John and Meryl. And they do staff dot append Brian. So is append destructive or non-destructive?
Destructive.
Mm-hmm. Yep, because if I check here, Brian is now a part of the staff. We've replaced the original array with this new array that has the extra one on top of it. And then if I want to get rid of Brian, I would say staff.pop. And then if I print staff again, it's a destructive method. So I'm just curious, do you think there's any reason why we want things to be destructive or non-destructive? Is there advantages to each?
In a lot of cases, memory would come into play.
Exactly. So this kind of gets down to, and we'll get more into detail about this later, about how memory is allocated in your computer, essentially, is because when I say first name equals Noah up here, I've essentially told my computer, I want you to allocate some memory to keep track of this string. It's 3 characters long, called Noah. And then whenever I reference first name, this variable, the variable isn't actually the data itself. It's just something that points to the data. And so when I run firstname.capitalize right here, what I'm essentially telling my computer is create some more data based on this, but don't change the original one. That one's still out there somewhere. So if I do, new first name equals firstname.capitalize, I've allocated more memory in my computer to keep track of that. But if I use a destructive method, like my array methods down here, I've allocated places in my memory, in my computer's memory, to keep track of these 4 things. And then I've said, okay, I want to change that structure that's saved in my memory with another thing. Don't create a new array. Edit the original one. And yeah, we're going to get into more detail about how memory is allocated later on, but that's the general idea, and that's that's kind of why methods can be destructive or non-destructive. So it all depends on how we interact with the memory in our computer. All right. Any other questions? Okay. In that case, that is the last thing I had for you today. So your challenges today, you're going to be working solo this time. First, go through the challenges in RegEx 1. So they start out pretty simple and they get more complicated as you go. And then I believe the other challenges today, phone numbers and stock picker, those are also all RegEx. So the destructive versus non-destructive thing, that was more something for you to understand. It's not relevant to today's challenges directly. And they also have a lot of different, in the curriculum page, we have a lot of great resources on RegEx. So at any point you get stuck, make sure you check those resources first because they're great, and finding out RegEx again, I think, is a lot of fun. So in that case, yeah, feel free to take a break, take an early lunch if you want to, and then get started on your challenges.
I just want to, with regards to the 2 challenges, they already have test specs written for you. So I would just run the test specs and then try to get those test specs to pass. So you'll kind of see it when you fork and clone the challenges, but they already have test specs written for you, and your goal is to try to pass all the test specs.
Thank you, Tom. All right, I will get off the Zoom room to put these videos up, and I will talk to you all later.